Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to go through some examples of how to use variation or concepts of variation to write equations and solve relative problems. So what we're going to do, we're going to look at problems number 4 and 6 on page 126 in your college algebra text. Starting with number 4, and I'm going to go ahead and read it here. It says, the distance S a ball will roll down an incline is directly proportional to the square of the time. If a ball rolls 8 feet in 1 second, how far will it roll? Right? So in this problem, I'm going to draw a quick picture here because for those of you who know me, you know I love my pictures. We got some sort of ball. It's rolling down this incline. As time goes on, the ball is going to be rolling faster and faster and faster. The distance S is this distance, and it's varying with t, with time. And when it states in the problem, the distance S is directly proportional to the square of the time. So that means that S is equal to some constant times time squared. Now it's important to realize, it didn't say S is proportional to time. If it did, we would write out S equals a constant times t. It said S is proportional to time squared. That means this is the correct proportional relationship, right? We don't want this one because it actually said time squared. Now the constant needs to be determined. We can determine that from the data in the problem. It said if the ball rolls 8 feet in 1 second, how far will it roll in 4 seconds? So I'm going to write this down. If t is equal to 1 second, then S is equal to 8 feet. And again, this was given in the problem. So what we can do here is we can use this data to find our constant. So S is equal to 8 feet equals a constant times t is equal to 1 second, and that's being squared. Now, to solve this for C, you're dividing both sides by 1 second squared. 1 second squared. Now you notice on this side they reduce. So our constant now is equal to, all right, numerically 8 over 1 is 8. Now our units, we got feet up top, second squared in the bottom, so I'll just put feet over second squared. Units are very, very important for application problems. Now that I know my constant, I can rewrite this equation. S equals 8 foot over second squared times t squared. And now if you tell me a time, I can tell you an S. Or if you give me an S, I can tell you a t. In this particular problem, it says how far will the ball roll in 4 seconds. So I'm going to go ahead and just put 4 seconds in for t. And then we just multiply this out. So let's see, we're going to have 8 times 4 squared. That's going to be what? 8 times 16. And unit-wise, foot over second squared times second squared gives us just feet. Let's see if we do this product. I believe that's 96 feet. Whoops. We're going to do the math on that again. Let's see, 16 times 8. 128 feet. Double check, make sure that's right. Yeah, I think that's good. Okay, so this ball should roll 128 feet in 4 seconds. Well, let's take a look at example number 2 here, number 6. It says, for a constant temperature, the pressure P of a gas varies inversely as the volume. Now, that sentence right there is enough for me to write out an equation. It says that P varies inversely with the volume. So that allows me to write the following. P has to equal some constant over the volume. Now, in the previous example, we ended up with a square on the right-hand side, and that's because in the previous example, it actually said the distance S varied with time squared. This doesn't say anything about the volume squared or square rooted or any other power. It just says the pressure varies inversely with the volume. That yields this mathematical relationship. Constant here needs to be determined. Now we're given some data here that the pressure is 70 pounds per square inch when the volume is 210 cubic feet. Find the pressure when the volume is 140 cubic feet. Okay, so what I'm going to do here is I'm going to use this data here to find the constant. So we're going to have 70 pounds per square inch equals a constant over the volume. The volume's 210 cubic feet. Now you'll notice this is square inches on the left, cubic feet on the right. I think this will work out just fine. I'm just going to pay very close attention to the units. So we would solve for C by multiplying both sides by 210 cubic feet. So we're going to have 70 pounds per square inch times 210 cubic feet. And when we do that multiplication, I get 14,700. Now I'm going to be real careful with the units here. Pound foot cubed over inch squared. And I think we'll be just fine with this, leaving these units just the way they are. So we can rewrite our equation. P equals a constant, 14,700, pound foot cubed over inch squared over V. And now, let's see, it says find the pressure when the volume is 140 cubic feet. So we're going to just take that 140 cubic feet and put it in there. So our pressure is going to equal 14,700 pound foot cubed per inch squared. Just leave that just the way it is, divided by a volume of 140 cubic feet. Now, numerically, we just have to calculate this. I get 105. Now, dimensionally here, we have this fraction divided by this. These are going to reduce, and we're just left with pounds per square inch. So, there's an example of how to work a problem involving inversely related variables. I hope that these examples help. Have a great day.